This video is about transformations. Transformations is an area of geometry where I begin with an object, which can be a point or a shape, and I change how it looks by either changing its location or its direction. One kind of transformation is a translation, and a translation is where I just slide my object from one position to another. I don't change the direction in which it's facing. Symmetry occurs when I reflect the object in an axis. Rotation occurs when I twist the object. And dilation occurs when I either scale the object up or down. In any of these cases, the resulting geometrical shape is called the image. So we start with the object and we end up with the image. In the Junior Cert course, we just focus on translation, symmetry, and rotation. So let's start with translation. I start with my object. If I'm required to do a translation, the rule for the translation will be written as 2 letters with an arrow above it. And this is simply an instruction to move the point, in this case A, to the point B. So I'm going to slide A from its current position over to B, and I'm going to use the exact same rule for all the other points on my object. So note that currently my point A is here. Well, now I'm going to slide A over to B. Note that all the other points of my object move in the same direction by the same amount. This new square, this new shape, is my image. Note that A has moved to B, D has moved to C, the point that was originally C has moved out further to the right, and the point that was originally B has moved out further to the right also. I'd like to give all the vertices of my geometrical shape in my image their own names, because A, B, C, D refers to the object. So I'm going to name these new vertices, these new positions for A, B, C, and D, A dash, B dash, C dash, and D dash. So while my object was the shape A, B, C, D, my image is the shape A dash, B dash, C dash, D dash. Let's look at what would happen if I had a slightly different rule. So I'm back to my original object again, A, B, C, D. This time, let's see the effect of the translation C to A. So this translation is instructing me to push the point C up to the point A. There's no twisting taking place, it's just a straight linear motion. I can see that with my translation, every point has moved in the same direction by the same amount. And again, while my object was A, B, C, D, my image is called A dash, B dash, C dash, D dash. Now, in some questions, I might be asked to draw the image. In some questions, I might be asked to figure out where each point on the object ends up after the translation. And in some questions, I might not be asked about the whole shape, only about a portion of the shape. So let's use the rule of translation CD for an example. So here I have my object, A, B, C, D. And here we have an example question, which says to find the image of B under CD. Now, first of all, how to read this question. So they're asking me, where is B going to end up if I use the translation rule CD? So the rule says C should go to D. So I'm going to take my object and I'm going to push it in that direction. So C is going to D and everything else is going to move by the same amount in the same direction. So my image is going to end up here. And let's just see where B ended up. So the point that was at C is now over at D, and the point that was at B is now over at A. So the image of B under CD is A. Another common question type is find the image of BC under CD. This time I'm being asked to take a line segment BC and move it using the rule CD. So we can see still up here in my diagram, my object was here. I've pushed my square in this case over so that C is now landing on D. When I want to move the line segment and show my work, what I'm going to do first of all is split up the line segment into its separate vertices. So I'm going to split it up into B and C and move them separately. So where did B move to? Well, we just realized a moment ago that B moved across to A. And where did C move to? Well, this is actually part of the rule that we've been dealing with. So C, we know, even looking at the translation, moved to D. You can see that also in our diagram, C moved across to D. So I had my line segment BC, and it's ended up in the position AD. When I go to write my answer at the end of this, I should write my answer in the same notation or in the same way as the shape that was moved, the shape that we started out with. So in this case, I'm using my line segment notation of my square brackets. My answer is best written as BC goes to AD. We sometimes also encounter translation on the coordinate plane. Here I have my object, which is the triangle ABC. Pause the video for a moment and write down the coordinates of the 3 points A, B and C. On this particular example, I want to use the translation +2 + 2. The first +2 refers to the x component of each coordinate, and the second +2 refers to the y part. So the effect of this particular translation is going to be to move every point 2 places to the right and 2 places up. So 2 places in the positive x direction and 2 places in the positive y direction. So I can see, for example, that A is going to move 2 over and 2 up, and take a moment to identify where it's located now. So A clearly moves to 3, 4, and I'm going to name that point A dash. Take a moment to see, can you find where the image of B, called B dash, and the image of C, called C dash, should be located. And it's possible to see here that we can do these translations visually using our grid on our coordinate plane, but equally we can use the rule for the translation to directly apply it to the coordinates of each point. So for example, since the rule is +2 + 2, 1 + 2 is 3, 2 + 2 is 4, 2 + 2 is 4, 5 + 2 is 7, 4 + 2 is 6, 3 + 2 is 5. We can see that if required, we can join up the points A dash, B dash, C dash, and they are going to give us a triangle that has the same size and shape as the original object ABC, but just in a different location. So it's like that object ABC has been slid in the direction +2 + 2. Can you think of a word to describe ABC and A dash, B dash, C dash? These two triangles, if they're the same size and the same shape, what word can I use to describe them? We can say that the triangle ABC is congruent to the triangle A dash, B dash, C dash.